Here we're going to discuss how to come up with the radian degree measures of a unit circle, similar to what we did with degrees, and this would be the radian equivalents of all of the degree angles that we came up with. So we're going to start with making sure you guys have the file, which is under the week 2 agenda, called unit circle radian degree, and it was the same set of notes that we had printed for the degree. I'm also going to ask that you have a blank sheet of paper or right on the back side of it when I move down and talk about coterminal angles. So we're going to start by just thinking of a unit circle really as slices of pies, in which pi is half of a revolution of a circle. So if we think about this as pi here, and we look at this as fractional values, we have 1 pi over 4, or a fourth of pi here, 2 pi over 4 here, 3 pi over 4 here, and 4 slices of pies to get to pi. So the way that I would indicate a 45-degree angle would be equivalent to dividing pi by 4. Pi over 2 is the same thing as 2 pi over 4. So this is 2 pi over 4 because the initial side being here, we've now spanned 2 pi over 4, which is the equivalent of pi over 2. Now if we just count, and let me go ahead and erase some of this so that we get the actual angles. So we left off at 2 pi over 4. This would be 3 pi over 4. And does it make sense that this would be 4 pi over 4, or when reduced, just pi? 5 pi over 4, 6 pi over 4, which when you reduce is 3 pi over 2, 7 pi over 4, and finally 8 pi over 4, which when reduced is equal to 2 pi. And we can keep going with this. We have that's 1 full revolution, but if we go past that revolution, then what we start talking about is coterminal angles. Okay, and so I just want to do a quick example on this since it's nicely laid out and drawn here for the circle. But if I wanted to keep going, this also would be equivalent to 9 pi over 4, where a coterminal angle is defined as it has the same initial side and the same terminal side. So pi over 4 and 9 pi over 4 share the same initial and terminal side. So the question is, how many times can I do this? Well, if I keep going, we have 10 pi over 4, 11 pi over 4, 12 pi over 4, and we can keep going around in an infinite number of ways. And so the question is, how do I tell the reader of, say, a problem that this is 9 pi over 4 instead of pi over 4? What we do is we draw, if it's pi over 4, we draw an arrow indicating that we've only gone 45 degrees, or pi over 4. Now, if I wanted to indicate that it's 9 pi over 4, I would draw the initial side and the terminal side the same way. But what I would do is draw a swirly to show that that's 360 degrees, kind of like a snail shell, and go past it 1 pi over 4 to get 9 pi over 4. Okay, so obviously we can keep going with that and add another 2 pi to get here, and we keep going. Notability does these fancy shapes, which I don't need. Okay, so again, the angle measures that you see, and I'll highlight it, are the ones that I expect that you guys know by heart, or at least to be able to come up with it. So they're going to show up in a lot of our problems, and just want to make sure you guys are able to come up with these measures when needed. I would recommend memorizing them. Okay, so down on the circle below here, we have that pi is now, instead of divided into 4s, divided into 6s. So it would make sense that this right here is 1/6 of pi. So this would be pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3, 5 pi over 6, 6 pi over 6, which is equivalent to pi, 7 pi over 6, 8 pi over 6, which when you reduce it is 4 pi over 3. A 9 pi over 6, which is 3 pi over 2. 10 pi over 6, which is equivalent to 5 pi over 3. And finally 11 pi over 6, where there's a total of 12 pi over 6 to get to 2 pi. And so in a similar way, you're going to want to remember these values here for, so 2 pi over 3, 5 pi over 6 is important, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, 2 pi. So now we're going to go ahead and move on to defining a coterminal angle. So go ahead and have your blank sheet of paper out and I'll write out the definition first. Okay, so a coterminal angle is an angle that shares the same initial and terminal side. So in that example above, I had shown you guys an example with pi over 4 and 9 pi over 4 being coterminal angles. So remember, you can have an infinite number of coterminal angles, and we can find coterminal angles. So to find coterminal angles, we want to make sure that we do a full revolution. So to find coterminal angles, add or subtract. If we're in degrees, add or subtract a full revolution, 360 degrees. Or if we're in radians, 2 pi, add or subtract 2 pi. So I'll do one example with you guys in terms of degrees and the other one in terms of radians. So find coterminal angles to an angle that has a measure of negative 200 degrees. Okay, and I believe sometimes they ask you guys to find that angle, find a coterminal. Remember, there's an infinite number of angles, but if I wanted to find a positive angle, I could. And if I wanted to find a negative angle by doing a negative revolution, I could as well. So let's get an idea of what negative 200 degrees. So if I had to sketch this in standard position, I would know that the initial side is on the positive x-axis and that I'm rotating in a clockwise degrees, and getting to here gives me 180 degrees. So I'm past that by negative 20 degrees. So that's negative 200 degrees. Now, if I wanted to find a coterminal angle that's positive, I'm going to go ahead and add 360 degrees to 200 and get 160 degrees. So that would indicate that I've gone and added 360 or one full revolution in a positive direction. And this angle right here should have the same initial side and the same terminal side as negative 200 degrees. Now, if I wanted to go in the negative direction, instead of adding 360, I would subtract 360 and get negative 560 degrees. Okay, let's try this with radians. So for the radian one, we're going to find positive and negative as well, but this time we're going to find coterminal angles to negative 7 pi over 6. So if I wanted the positive angle, I would take negative 7 pi over 6 and add 2 pi to that. Well, this is a matter of fractions, and I need a common denominator to 7 pi over 6, which is 6. So if I make 2 pi in terms of 6, there's 12 pi over 6 is equal to 2 pi. And if I add the 2, I get a positive angle of 5 pi over 6, which would be the positive coterminal angle. And remember, you can keep adding 2 pi to this. There's an infinite number of coterminal angles, but we're only going to go ahead and list one. So now a negative coterminal angle would be equivalent to going in, it's already negative, so we're going to subtract 2 pi instead and go in the opposite direction, which is going to get us get us to a point where we're subtracting 12 pi over 6 instead of adding 12 pi over 6, which is equivalent to negative 19 pi over 6. And so this angle here and this angle here shares the same initial side and terminal side as the initial angle, and that's coterminal angle.